What's up guys, Shawnthebro here, and today we're going to be going over quests part 3. In this episode we'll be able to actually finish off our objectives in a quest and then finish a quest. So we don't have any logic to switch between quests or have main quests and side quests at this point, but we will be able to finish the quest that is on the screen that is assigned to our character in our game mode as base quest. So, let me show you how this works. So we have slay 2 pumpkin golem and collect 2 pickups. Now, the pumpkin golem, remember, ignore his weird movement. It's because I was testing some things with physics enabled on the character. You can see once I've defeated him, I've slain 1. I only have 1 in the level, and I have not stopped the logic from punching the same one to do it. And you can see as I've punched him again, then I've completed that objective. If we go to the output log, you can see you need to perform that action 1 more time. So that was slaying the pumpkin golem. Then I need to perform that action 0 more times because it thinks I've killed him twice now. Now you have completed objective 0, and objective 0 was the slaying of the pumpkin golem. So now we have to collect 2 pickups. So I can run into any pickups, and there we go. We can continue picking these things up, and you can see the counter keeps decreasing because we haven't changed quests. So the objectives are technically still there until we have main quest, sub-quest, or just a chain of quests that we can then switch between. It's going to stay like this, how it is now. But we are actually finished with the quest as well at this point. We've finished everything that we need to, and we could, from this point on, proceed. So let's go into the code and see how we did it. First things first, in the third-person tutorial game mode, which is basically our base game mode, I've added a few things. So this was empty before. It just had the constructor and all the generated body and stuff. But we're going to be using some stuff, and a lot of stuff that we used in the other quest episodes. So before we get started here, if you want to catch up on the series and you want to implement this, then I will leave a link in the top right corner in this iCard to cover basically everything we've done in the series so far. This will be the first episode of this series. However, while we are going to use a lot of stuff from the other episodes, the most important episodes are the quest episodes. You could get by just watching those if this is all you're interested in. So I'll leave a link right here to those 2 episodes. And now we can get started. So we had our base quest logic, and we had nothing in game mode yet. We had all of our logic for the game mode in the game mode blueprint. Today we're going to be adding some logic to the code. In fact, we're just going to be adding implementable events that we can use in the game mode BP, but we're going to add them to the game mode. That way we can just trigger them right away in the game mode BP and define the logic in there. So I've gone ahead and added update objective HUD, hide objective, and hide quest. Update objective HUD is what I'm referring to. You can see how the value of the thing that we need. So slay 2 pumpkin golem. When I slay 1, then you can see it goes to slay 1 pumpkin golem. And when I collect a pickup, it goes to collect 1 pickups. And then I can go ahead and of course complete these in the whatever order I want. But you can see the number actually decreased as opposed to just staying the same. You could also just have a counter next to it and have like 0 of 2 and add to that counter. Whatever you want to do, the logic will be pretty much the same. This method's going to be a little bit more annoying to implement, but I think it looks a little bit nicer. That's what update objective HUD is. Now, hide objective is how it disappears once we complete the objective. With the these both have the objective number, so the objective to update and the objective to hide. Then we have hide quest, which will hide the quest. It is technically in place right now, but we don't have anything else to do with it. We don't have another quest to pop up at the moment. So there's not much I'm going to do here. I'm probably just going to hide it and then pop up the next quest in the story, or hide it and then, mark a waypoint to the next quest, something like that. We'll figure that out as we do another quest part. I haven't added anything to the game mode CPP, so you don't have to worry about that. Now, back in basequest.h. There's a few things we have to add here, but everything is pretty much the same. in terms of the functions that are here and the variables that are here. In fact, I don't think we've changed anything that was already in place. But we need to add some things just to make everything be able to grab the values they need. So for example, the objective, we couldn't update it before because the objective was kind of baked in to the UI. Not quite baked in like the artist sense, if you're familiar with that term, but I'm referring to baked in here as we made it. Okay, we made the text in the UI, and then it was kind of just static. There wasn't anything we could do to change it. We didn't have a reference to. We had the description that we put in, but that was it. We didn't separate the number from the text or anything. So what I mean is, again, so you see how this goes from Slay 2 Pumpkin Golem to Slay 1 Pumpkin Golem. Well, this was just all getting appended into one block of text. It's not like I could just grab the number and change it. I mean, I could. But if I don't know what the number is, and if I want to make a modular system that can work with any quest to update it, then I'm going to need to pick up, specific values. So not every quest or objective may have a number. So it's possible, you don't want to do this. You may just want to do the counter. So if you have like 0 of 2, 1 of 2 on the right side of the text here, there's a bunch of different ways you could do it, and you might not have to do what we're doing here. But if you want to have the objectives like I have them, where they actually work in real time with what you're doing, and then hide themselves once you're complete, then if you actually want to do that, what we have to do here is I've added a function called update objective description. I pass it in fstring description, which is a reference. I'll explain this in a second. And the num required. So the num that we want to replace and change out the actual number in the quest description with. So from going from Slay 2 Pumpkin Golem to Slay 1, the num required would be 1 in that case. That's the number we're updating here. And now I do have finish objective and finish quest as well. These were already here before, but these are going to be important in this episode. We're going to add more logic to them. So just make sure that you've got them and that they look like this. Alright, let's go into the base quest.cpp and cover some of the logic. First things first, before we do anything else, let's look at the update objective description. Let's write this and then we'll show kind of where we call all of the new functions that we made. So update objective description. Now remember, this is the fstring reference description and the number required that we're going to replace this with. So the reason I made this a reference, this little ampersand, it's the and sign if you're not familiar with it. You can put this next to a variable type, or you could actually put it next to the variable name here on the other side, either way. What this actually does is it basically passes in the actual string that we're passing in here. So normally, if you were to just make a variable, then it makes a copy of that variable and passes it into the function. Now, I want to change this variable within the function. I want to change this description in the function. You can see I'm setting it equal to things in this function. And because I'm changing it, then I can actually just pass in the variable as a reference. That way I'm not passing in a copy of the f string. And there, when I change it here, the changes will be a lot more efficient because they're changing on the variable itself. It's not storing a copy and then trying to set it later. You don't have to force anything to be set afterward or set equal to a return value. You can just set it directly in here. So this is one way to do it, and I just kind of want to teach you about that if you're not familiar, because these can be very good for memory and for performance, especially if you have these larger functions. So anytime I have like a string updating or string parsing function, I like to do that because they're a little bit more costly than you'd probably expect. So it's pretty nice, pretty good to be as clean as possible with these. Now this function is a little bit crazy. You're not going to see me do functions like this very often, but I couldn't think of a better modular way to do it. Essentially what I've done is I've in my objective, I've added a manual set of characters that we can look for to split the function, extract the data, replace the data, and then, update the actual description. In this case, I've used I've used the keyword, if you will, the specific string, specific sequence of characters as these angled brackets with NR in the middle, which is actually num required, is what that stands for. Let me show you where I've added that now. So this is the new function we're making. But in the setup objective function that we already had, this is where we're setting all of our data for the objective. And I've been appending the description 1, num required, and description 2. I do description 1 plus, and then I have quotes with angled brackets NR. And then for description 2, on my third append here, after I've appended num required, I have NR. And the reason for this, again, it's kind of hard to tell what we need to extrapolate from the description. Because think about it this way. So you're like, oh, just, we're just slaying 2 pumpkin golems, just grab the number. But you could easily have a quest where it's like, slay 2 android 2s or something. Like, if your name is android 2, you don't want to replace that. I want to be slay 2 android 2s to slay 1 android 1. That's not how that would work. So you have to be careful. If the text in the description could be mistaken here for the num required, or just if you tried to grab every integer, it's possible it could cause issues. Now, in most of the cases, this probably won't happen, so you'd be pretty safe, but I'm trying to cover every case. So what I've done is added these little sequence of strings, okay, so that they wrap directly around the num required. So the way this looks right now is like this. Actually, here, I'll just show you. It looks like so if my num required is this, then it's like slay okay, it looks like this right now. This is what the string looks like. So you can see that the num required keywords here, they directly are on top of this number. So now when we go back to our update objective description, this will make a little bit more sense. I will try and update this notepad as we go along this function so you can kind of see what's going on here. So in this function, I make 3 F strings. Now you could definitely clean this up a little bit. So if you're more familiar with coding, then feel free to make this a little bit neater and a little bit better performance-wise. But this is good for now, and quite frankly, it'll be good the whole time. We might just clean it up, adjust the number of strings we have in here and things like that. But I made a first string, a second string, which will make more sense in a second, and then updated num. So the reason I have this updated num string is just because when you're trying to append an integer to a string, you have to specifically call append int, and I didn't want to deal with it within all this logic that I'm doing because it gets kind of complicated here. So I just went ahead and made an F string. I updated num, and then instantly I did updated num.append int, the num required that's passed in. So let me write down what all these values are to make a little bit more sense for you. So first string, we'll have that. We'll have second string. Space these out a little bit for you. And then updated num. So updated num after this appendant is whatever is num required. So let's go with the pumpkin golem case. Num required is 1. Excuse me, not 2. It's 1. Because it's originally 2. If we've slain 1, then this function is going to get called once, which means the updated num will be 1 in this case. Remember, that could change because if you have like collect 500 experience and you collect the pickup worth 10 experience, then your new number is 490, not 499. So it is important to make that differentiation. Okay, so first string and second string. Now these aren't set yet. Let's go into this and I'll show you how they get set. There's an F string function called split. And what split does is it takes a string that you give it, it finds a substring or a character within the string, and it will split into two strings at that point. So you'll have a left side and a right side. So I'm doing description. This is the string that I passed in. For the record, where I call update objective description, I call update objective description in the update objective function. So update objective is what we already made in the past, and basically this is where we had the value being updated so that we could finish the objective. We had this last episode, but it wasn't changing the description, and we didn't do anything once we'd reached the end. We just showed that we could actually track the number of that object that we needed, such as slaying 2 pumpkin golems, and then actually complete the objective. And these were all being printed out to the log. But now what I'm doing is right before where I update the value, I'm then going ahead and passing in some data to this update objective description function call. So call it right down below, and I'm passing in objectives, objective num dot description. So remember, the objective num is the number of the objective that we're trying to edit and or update. In this case, objective 0 refers to the slay 2 pumpkin golems. So this would be objective 0 dot description, just slay 2 pumpkin golems, and then objectives objective num dot num required. So it's 2 normally, but our update value, or our num required, subtracts and sets itself equal to the update value. So the update value after slaying 1 pumpkin golem would be 1. 2 minus equals 1 is equal to 1. So we're passing in a num required of 1, and that's how we get these values that we do in here. That's how we get the values we set up here, like how I said updated num is 1. Okay, so now we do this split, right? This split is splitting on the sequence of characters that we chose. So you can make it whatever you want. I made it angled brackets with NR in the middle. So we're going to split on that. Now, when we split on that, it wants you to pass by reference 2 strings that it can set the first string and the second string to. That's what these two F strings are for. So make sure you put the ampersand in front, but then do first string, comma, second string. Now, these are set by now. So this is how this looks. Slay with a space. Okay. That's first string. And second string is equal to the number that it is, which is 2 right now. So when you split a string, the substring that you split on disappears. That is very important to note. So now it's 2 NR. It only splits on the first instance of that substring. So unless you did it again, this NR is still going to be here. So it's 2 NR pumpkin golem. Alright, so these are what our 2 strings look like. And now the reason I split here and separated this is because you can tell the first character after the split is going to be the value we want. But not just the first character. Not just the first character. Everything that's before the next NR. So this could be 200. Okay, so you just want the first character because then you'd only grab the 2 from that. But everything before the next sequence of characters that we care about is what's important to change the number out for. Okay, so you can see I'm doing something a little bit complex here. This is called daisy chaining, where you do a bunch of functions in a row within the same line to achieve the result you want. So I do second string is equal to second string dot replace, and then I dereference second string dot left to call second string dot find NR with the updated num. Now, that probably doesn't make a lot of sense. I mean, even reading it, even knowing what it does, is a little confusing. So let's go through this one step at a time. So let's go at the base level here of what we're doing. So we have updated num dereferenced. Now, when you see a pointer sign, an asterisk before a string, you're doing what's called dereferencing it. It's basically just you grabbing its internal value to use in a different area. Like, for example, I'm calling replace here, and replace is requiring, it wants 2 tchar pointers. You see up by the replace here, at the very top line of this box that popped up, it says constant tchar asterisk from, constant tchar asterisk to. So those are tchar pointers, or tchar pointers, if you will. Basically, they're character pointers. That's all you need to know. And dereferencing F strings will get you that value. So don't get confused by these signs, really. It's not going to be important right now that you know what this is being used for. Just know when you have to see a tchar pointer like that, then you need to dereference an f string to grab the value out of it. So this is coming from the replace function. Okay? That's what this is for. The find here is grabbing the index. What find does is it grabs the index of what you've got here. And you can see it returns the index into the string. Alright? So we're grabbing the index where this string starts. Remember, since we've split the string, there's only one more case of this sequence of characters. It's in second string, and it's right after the data that we want to change. So if this is 2, 2000, 75, it makes no difference. The angle brackets with an NR in the middle will be right after the value that we want to change and update. So by finding this sequence of characters, it returns the first index here. So the first index here in this string is 1, because indices start at 0. So this value, the 2 value here in this string, is the 0 index in this string. But index 1 is this left angled bracket. So at this point, we know everything to the left of that is fair game for what we want to update. So let's keep following this. We find the index of that. We found index 1. Then we grab second string dot left of this. So what that means, let me hover over left for you. It returns the leftmost given number of characters and a count. Well, what we want to return the left amount of the characters to the left of our string that we put in. So if our index is 1 and we're passing in an index of 1, then everything to the left of that, which in this case is just index 0, will be added, will be set to this operation, this second string dot left. All right. So let me break this down. That way it's a little bit more easily seen. So the first things first is we do second string dot find, and we find our value. Okay, so we do it like this. This is second string dot find. Now, what this actually evaluates to is 1. Find returns the index of the string. So this returns a 1. Now, second string dot left. Second string dot left. And if you realize it's left of, you see the parameter that's being put in here, left of this find operation. So it looks like this. Right? Now this is everything to the left. It actually returns a string, an F string. It returns everything to the left of that index. So the index is 1 in this case. Everything to the left of index 1 in the second string is 2. It's literally just this character. Again, if this was 200, then this would start at index 3. So everything before index 3 would be equal to this string. But it's only 2 right now. So this is equal to 2. Okay. Alright, so that's how that's working so far. Now, we have one more thing that we do here. We do second string dot replace. So what replace does is it takes in one string. It basically takes in the value that we want to replace and then replaces it with the value that we want to replace it with. So this is the from, the first parameter, and the replace is this value. Okay, the result of this operation right here. What we're trying to replace it with is this updated num value, which is the string that we appended num required to. Now remember, updated num is 1. So what we're essentially doing here, I know it's a lot mixed together, but we're taking this string, okay, we're doing this operation, and at the very base of this, we're replacing 2 with 1. That's all we're doing. We're replacing, if it helps, we're replacing this operation here. So if I said A equals this, B equals this, C equals this, what we're doing is we're replacing B with updated num. Okay? We're replacing B with updated num here. Now remember, don't get confused by the asterisks you see. So this is just the dereference. It doesn't change the value. This is just specifically so we can get our f-string data into our replace function so that it compiles. Okay? And then C is what we want. C is the final version of the second string here. So C looks like this. At this point, C actually looks like this. There you go. So this is what C looks like right now. Alright, and C, remember, is just second string. Okay? So there's no need to get confused by this. There's a lot going on, but once you see it, hopefully this makes a lot more sense. What we've done is grabbed everything that was in the middle of our two sequence of characters, and that happened to be 2 in this case. We had our updated value that we wanted to replace that value with, which was 1, and then we did an operation to find all the characters that were in the middle of these and replace that value with the updated num value. Now what we need to do is remake the string. So that's what we're doing on this final line here. So we're taking the first string, we're appending the sequence of characters again, and then we're appending the second string to that. So I'm going to put this as final string. Final string is this last line in this function right here. And it's being equal to slay, that's first string. There's a space after slay, remember I mentioned that, just by the way I set it up. So it's slay, space. I'm appending NR. I'll show you why I'm appending this again at the end. Okay? And then it's just the rest of this string right here. Alright, you see how that works? Now the reason I'm appending that again, it's not entirely necessary. So appending NR again, like I did here, was just so that I don't have to continually check to see if there's 1 or 2 of these. We can actually hide all these in the string that we output. So you could have 80 of these on top of each other if you wanted, and we can hide them all in a single operation. So having these in here, as long as you're using the same keywords, or you can even mix it up if you had specific, if you wanted to do different operations on different keywords here, then you could hide all of these in a single operation that takes about 10 seconds. I'll show you how to do it. And the player will never see these. So now they're here in our function, and we can continuously use them when we want to make changes to this objective or this quest, and we'll be good to go. So that's how I've done this, okay? This is the whole string. I'll go ahead and save this real quick. Now we call this update objective description example. I'm going to close this now, but this is the whole function. If it doesn't make too much sense, it's okay. I would honestly just copy it in this case. This is one of the things you can play around with it. You can see what the actual value is, and then it should make sense. It should make more sense. Alright. Now, after this function call, so after the description has been updated, we do want to represent that description update on the HUD, on our character screen. So the function that we made earlier, which was update objective HUD with the objective number, is what's meant to do that. We need a game mode reference, and we don't have one in the quest, but since we're only going to ever use the game mode once or twice in the quest, I haven't made a variable yet. Maybe we will later if we decide to do more with it, but as of now, it's not really worth having an entire game mode reference variable. So I'm going to show you how to do it without. If you want to make a variable, go for it. I'm just trying to be as cost efficient as possible right now before we need an actual reference. So the way this works is, first of all, to be able to use the game mode at all, you'll need to include the game mode. Oops. You need to include the game mode at the top of your file here. Include third-person tutorial game mode. Then it becomes a type you can use. So what I do here is this line. If auto game mode ref equals cast to our game mode type, and then get outer is the object we're casting. Let me explain. So this is a UObject class, not an actor class. UObjects, remember, they're not really things in the scene. They're kind of just things that exist in memory that we can pull data from. So getOuter essentially grabs the parent object. See, returns the UObject this object resides in. So we're trying to get the getOuter to be the game mode. I mean, the game mode is where we spawn it and set values to it, so it would make sense that this game mode reference, the outer object of this casted to a third-person tutorial game mode, would be our game mode reference. So it makes a lot of sense. The reason I put this in an if statement, if this cast fails for whatever reason, it won't try and do this logic, and then you can avoid a crash. So that's good too. And auto, you could make this your game mode. I'm just being lazy. Auto will automatically get the type for you. It's technically a little bit slower than just putting in the right type, but by just a small fraction of a second, you're perfectly fine to use this. Then finally, I used game mode ref that we just created to call update objective HUD, and I just pass in objective num, which is already in update objective. So you don't have to do anything special there, just pass it in. Now this logic was already from episode 2. Basically, I checked if the num required on this objective was less than or equal to 0, meaning we'd already done everything we need to do for this objective. Then we call finish objective. In finish objective, all we have to do is hide it if we feel like we are actually finished with it, and we don't need it to come back. Now you can play an animation or something to spice it up. For now, we're just going to be setting it to be invisible essentially, and removing it from the vertical box that it's stored in, so you can't see it in the HUD anymore. So I do the exact same thing that I did before, because this is the other time I'm using it. And then I call game mode ref hide objective with the objective num. Now remember, these are all blueprint implementable events, so we will get to them when we get into the blueprint side, which is coming up soon. But you call it here. We were also just checking if the number finished quest was greater than or equal to the objectives.num. So basically how many objectives were in the quest. If we've completed that many or more, then we can finish the quest. And in this logic, I'm pretty sure in last episode, finished quest didn't have anything in it. So what I've done is I've added a log to say you have completed the quest, and I pass in the name of the quest. Again, another dereference here. That way you can see the name of the quest when we complete it. And then I also take the game mode reference one final time and call hide quest. Okay, make sure you build solution, and then go into Unreal Editor, and then compile if necessary, if it does not hot reload among build. Okay, so as far as the blueprint goes, we just basically need to actually fill out the functionality for the implementable events, and then also we're going to set up the collectibles to work for the objectives as well. Now in the base enemy BP, I just want to bring up that we were grabbing the class type and checking if it was equal. This will only work if it's actually equal. So for example, base enemy BP happens to be my pumpkin golem. But if I had a child of that, this actually would not work, believe it or not. And that's because it's checking for the specific class type. So in our collectible, we'll set this up first. You can copy and paste everything from the base enemy BP. But instead of doing enemy to slay, first of all, drag off of item to collect. But then get the class type, and instead of checking if it's equal, check if the class is a child of that class, if you need to do any sort of child operation. You could also do class is child of or is equal to, and then it'll encompass all your possibilities. Just, you have to do it with what you're going to need for your objective. So that's up to you. If you want the children, if you want to every time specify the exact child. So for example, like, yes, I'm choosing base enemy BP, but I might not want a child. Maybe I do want that parent. So you could do equal sometimes, you could do as a child of, or you could do both. You could do an or if statement. I've also gone ahead and made a base collectible BP. I should have mentioned this. So this isn't technically any of the collectibles I already have. Now you guys are familiar with my other collectible objects that I have, and if you're not, I'll leave a link in this iCard right here. But they're pretty simple. I have damage, experience, health, and shields. I made a base one. I literally just made a new blueprint class and made it a child of the default item code class that we have. And then every one after that, all these guys, they were just actors before, or I think they might have even just been like static meshes before. I just changed their parent class to be the base collectible BP. It doesn't change anything on the actual collectible end. The only thing you have to add is I have this event notify collected, the same way we did it with enemies. In my default item class, I have a blueprint implementable event, and I've also made a blueprint callable called void notify collected. That way, whenever we collide with this object, we can call notify collected and update the description. Again, the exact same process as the enemy. The enemy had like notify death. It's the exact same thing. The only reason this one is blueprint callable is because I'm going to be determining the collision with the collectible in blueprint. So I do want to be able to call it within blueprint when that collision occurs. So you can see here, this is the base collectible BP. I have begin overlap, and if I overlap with the character that I'm looking for, I call notify collected. And then this is, again, the exact same logic as we had in the enemy. I just changed the item to collect to be class is child of. Okay? So this is simple enough. A little bit of a snag here is that because the overlap is a little bit different, it's not always going to be on the same static mesh component. You do have to do on component begin overlap every time, perform your logic, and call notify collected for each collectible you have. So I've done this for damage, experience, health, and shields. Then in all of these 4 children collectibles that I have, I also grab the event notify collected. Remember, since this is now a child of base collectible BP, which is a child of default item, we can grab this event from any of these. So click event notify collected, and then you can call the parent notify collected. This way we don't have to do any additional functionality within the children classes. So you can right click on an event and do add call to parent function, and then just drag it in. And at this point, now whatever is in the parent, which again, base collectible BP, all this logic will occur for all of those collectibles. Okay, so I know I went over that kind of fast, but that's because the collectibles are kind of, there's going to be so many things that we could do separately in all of our games. So it's important that you know how, but it is also important that we just have the general process down, and then once the general process is down, you can update it to your liking. So I just feel it's not too important. We have everything exactly the same. Alright, and now the last real thing we need to do here is fill out all of the data for those 3 events that I keep bringing up, the ones we made in the game mode code class. So these events, I'm actually going to close some of these things. Okay, these events were update objective HUD, hide objective, and hide quest. So let's start with update objective HUD. That's the most complicated. Update objective HUD is what was going through, and it's supposed to change the text that is on the objective that we're currently using. Now remember, we updated the text and code in our, I believe it was called update objective description. But after that, we had called update objective HUD, and we had to pass in the new description essentially. We had to use the new description to change the description at that objective num. So you go and you can call event, and then you can type in the name. So hide objective, hide quest, and update objective HUD. All 3 of these, bring them onto the screen. They will automatically have their parameters that we put into them, and we can just jump right into it. First things first, we want to loop through and get the specific child that is relevant to this. So our objectives in our quest are getting added to this vertical array, this vertical box. We had a HUD reference from last episode, and the HUD reference is our character HUD class. So the character HUD had a vertical box on it. We can go to it really quickly. and this was the quest name and data, and then this was the objective vertical box. So it's a vertical box where we just add objective info boxes to it. Right? So we're grabbing the HUD reference, we're grabbing the objective vertical box from that, we're calling get all children off of that, and we're going to loop through them. You can do for each loop or for each loop with break, it's up to you. In this case I used the one with break, but I haven't broken out of it yet for any reason. And we're looping through, we're going to cast and make sure that the child is an objective info type, and then we're going to grab a bunch of data from this to determine if this is the correct objective, and then we're going to update the description. So you can see I brought my objective num all the way down here. This is the green line below this cast. Now, you can see I'm using something called objective ID. So in our objective info widget, this is where our objective data is stored. We had nothing in here, okay? We just had this box and it had text here, and we were forcing the text to do the text of the objective, the text that was the description variable of the objective. Well, now we need to kind of be able to adjust the text a bit and make sure that it is actually accurate for what we need. So we're still going to be calling objective description text set text with the text that comes into description, but we need to eliminate the special character sequences that we had added to be able to parse the strings and extrapolate the data that we had, to extract the data that we had. So in our set objective description text, we had already made this in a previous episode, grab the description and do toString text. You'll get this node. Then off of that, you want to call replace. Now I already have it right here, so we'll just do it here. Okay, but that's the source string. Then what we're replacing from to to. So I'm replacing the angled brackets with NR in the middle to nothing. Basically, I'm just removing them. But replace is especially good for this because it replaces all occurrences of a substring in the string. So instead of removing at a specific substring or finding it and removing it, we can replace all instances for basically just replace them to nothing, and you're essentially remove them at all locations. I ignore the case because, I mean, it's a hard-coded substring. I know exactly what this is, so it doesn't matter. Then you can drag this into your setText function. It will automatically do this toText string conversion for you. Okay, so that eliminates the characters we don't want to see in our objective. That's good. But we also need one other thing. We need to set the objective ID because we need to have an objective tied to this widget. As of now, we were creating them and just adding them as a child to the vertical box. So you can see we were creating the objective info widget, we were setting the text, and then we were adding the child to the vertical box. Well, that's good, but now that we need to access that objective to be able to change the value of it, we need to have some way to identify it, to pick it out. And to pick it out all the time as opposed to looking for some hard-coded value. So what I've done is I've added a custom event in here called set objective ID. You can right-click, add custom event. I called mine set objective ID. I gave it an integer as an input, and I called it ID. Then, lastly, I made a variable that was an integer called objective ID. And I'm setting the objective ID equal to the ID that's passed into this event. And now we can actually use the objective ID to parse these different children, basically to loop through the children and determine which one has this ID. And once it has this ID, we know we're on the right child to edit. Now we're going to go back to our base game mode BP. When we're adding them, this is in begin play right now. This is when we were setting up the quest objectives. This is when we're setting the quest name and description. And then this is when we're setting up the objectives for the quest. After I create it and before I set the text, although it doesn't really matter as long as you do this before you add the objective to the vertical box, make sure you call set objective ID and pass in the objective ID from this break objectives node that we have. So you were grabbing the description from this to set the objective description text, grab the objective ID from that and set the ID here. Now, our widgets in this vertical box are tied to an objective ID. So each one of these objectives in our quests will now have a number assigned to them. And guess what? That number links up with the actual objective number that they have that we ordered them in code with. So now we can actually just compare the two objective numbers, and if they're equal, we know that that is the objective we want to update. That's the description we have to change. Quick refresher. Update objective HUD, this event. The objective number is the ID of the objective we want to change. So remember, we loop through our children here, and we make sure it's in objective info. Then we grab the objective ID for that. Now, if this is equal to the objective number that got passed in, this green line back here, if it's true, then we set the objective description text. Okay? If it's false, we don't do anything. It's not the objective we want to change. We should not touch it. But if it's true, we change the text. Now, the way we get the proper text is we do the same way we set it up, essentially. So we grab the current quest reference, we grab their objectives, we get the ID that was passed in because that's the only objective we care about. We don't have to loop through them at this point. Then we break the objective, and the way you can do that is literally drag off of your get node and call break. You grab your description now, because it should have already been updated in code. We update the description before we call the update objective HUD function. So this logic has already gone through, updated the string, and we just pass it into the set objective description text as the description. And at that point, your text on your objective will actually be updating. It should be updating. Now the only thing it might not do, well, the only thing it won't do is hide itself once you complete it. So I can slay this pumpkin golem, and I can collect these 2 pickups, and the stuff would not hide itself. But it would go down. It would probably go into the negative numbers as opposed to just staying at 0. So now let's go ahead and hide these things. That way you can see that you're making good progress. Now, for event hide objective, you're going to see this starts off actually exactly the same. And basically, the logic is exactly the same. The only difference in this one is we're going to be removing child at the end as opposed to updating the description. So if you'd like, go ahead and copy this entire block, everything that's in this event, and just remove this bottom part here. Okay? So make sure you still have this green line connected. You don't want to have any broken links. You can see how I've done it here. But this is literally copy-paste. We have the same 4 nodes at the start. The green line comes in, and then we check the objective ID of that child to the objective num that got passed into hide objective. Then we do a branch, and if it's true, we do our logic. The only real difference here, as I said, is this logic that is used to pass into set objective description text is no longer needed, and this function call needs to now be remove child. So once you've copied and pasted, I'll show you how we can do remove child. Remove child is called on the vertical box. Essentially, we're taking the vertical box and we're going to remove this objective info that matches the data we want from the vertical box. The vertical box will automatically shift the elements up. If it's the first element, the elements below will automatically become the new top elements. So you get a nice little effect there too. Okay, so grab your objective vertical box that you have at the beginning here. You can see I've used a node to bring it all the way over there. So this bottom blue line is our vertical box. You can drag off of this and call remove child. And then you can just pass it the exact child we want to remove. If this is true that our objective ID is equal to the objective num we passed in, then we know this is the quest we have completed. Thus we can just get rid of it. So literally just drag from objective info, drag it into content, and it will remove that from the vertical array. Now the last thing to do is remove the quest from parent. The way this works is I grab the HUD reference, I grab the quest info from the HUD, which is the top panel here, and I just call remove from parent. Now if I play the game and I beat the heck out of the pumpkin golem and I complete my quest, you can see the quest goes away. So So the reason the quest wasn't going away at the start of this episode is just because Unreal decided that it didn't want to save my changes, save my compiled changes, so I had to recompile. Once I recompiled, everything was working as intended. There you go. So now you can see my quest goes away. Now I'm questless at the point, so I'm kind of just sitting here running around, and that's why we need something else to do once we complete that quest. Either fill in with another quest automatically, depending on our game, or we have to go get a quest. So we can work on multiple story quests, or just multiple quests at a time, you know, main quests, sub-quests, whatever, and switching between them in the future. I'm going to take a break off of quests this next week. This next time we do the action RPG tutorial, I'm actually going to do blend spaces with dual wielding. So we're going to be able to dual wield weapons and switch between them, and switch which attack we do between them. That's a requested video, so I want to take the time to actually honor and do that, because I think we're at a good stopping point here for quests at the moment. But when that's done, I will pick back up, and we will do, you know, juggling multiple quests and switching between them, maybe even waypoints as well. Although it's kind of hard on the small map, but you'll be able to see how they can get working on even a small scale. They don't get much harder as you get bigger. You just have to go more distance. Alright guys, so that's all I got for you today. I hope this helped you. If it did, please subscribe. It does more for the channel than anything else you can do. And it just lets me know that I'm doing a good job. I really, really like the way this quest system turned out. I'm very proud of it. I'm very happy about it. I want to give a huge shout out to my YouTube membership and Patreon supporters. Thank you guys for continuing to support me for all these series and just for all this time, just to show that you care and that you believe in the series. Thank you. It really makes it makes a big difference. If you guys would like to come watch me program, I'll be doing programming streams every Friday on this channel, and I will also be doing some programming streams on Twitch, twitch.tv/Shawnthebro27. I don't have a definitive schedule for there, but I know that you guys really want this on YouTube at this point, so I will be continuing YouTube every Friday here on this channel. But if you want to check out my Twitch channel, we will also be doing some fun programming streams on there, maybe unrelated to the current series that we're doing. I also play Dark Souls on there every Wednesday, so if you guys had any issues with this series or this tutorial or any of my tutorials, feel free to join the Discord community. You can ask questions in there, and we can get you some help with some pictures and videos as well if needed. Thank you guys so much for all the love and support and for watching this video. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.